In this video we will talk about scanned materials in V-Ray. We will first explore how the scanning process works, then check out the workflow, how to use and customize the scanned materials, and finally talk about their pros and cons. So in this video I wanted to talk about scanned materials in V-Ray, and we're gonna use this simple dummy scene here to test this out. As usual, you can always find all my scene files on my Patreon, but now let's first talk about what scanned materials in V-Ray actually are. So since a few years already, Chaos offers an additional service which is called VRScans. I think initially it was called VRScans. And with this service, as you can see, you can purchase this here separately. You get access to a huge library of different kind of scanned materials that you can use in V-Ray or other Chaos products. So as you can see, you can purchase this here either separately, or what I think makes much more sense, to include this in a V-Ray premium subscription, where VRScans and also additional goodies such as Phoenix or Chaos Player is already included. Also, as I read, V-Ray 6 doesn't require an own render license to render V-Ray scanned materials. So you can always render them, no matter if you have a license or not. Just with a license, you have access to the huge library and all the parameters of the material. So now with more people having access to these scanned materials, either through their premium subscription or by just being able to render those materials, I thought it's a good idea to explore how to use them. What are the benefits? What are the disadvantages, which it also has, and when and in what cases you should or could use them. So let's first briefly understand how a material scanner works. And what we have here is not the scanner from Chaos, because the information they post about their own scanner online is very, very limited. This one is from the University of Bonn in Germany, but in theory they should work pretty much the same. So as you can see, there's a bunch of different elements, and I try to mark out the most important ones. We have the material sample here placed at the very center, and then we have this kind of frame structure that has the shape of a half dome, which is placed 360 degrees around our material sample in the center. And then on the frame we have a bunch of different elements mounted. So first of all, we have a bunch of different cameras mounted on the frame, and there's one facing top down directly straight on the material sample, and then several cameras from different kind of angles until we get a very shallow angle with this lowest camera in here. With this you can capture a huge variety of viewing angles of this material. Then also on the frame we have a lot of these individual lights here placed, and once the capturing process would start, the whole light in the room would be switched off, and the material sample would be only illuminated by individual lights from our frame, and then thousands of pictures would be taken with individual light configurations and individual viewing angles here of this material sample, and then all saved out. So in the end you end up with thousands of pictures of this material sample, and now the question is how you can get the data out of all of those pictures here. So there are basically two different methods, and one is called BRDF, the other one is called BTF. And without going too much into the details, the BRDF method basically analyzes all the pictures that we acquired in here and then tries to find parameters and rebuilds a material that matches the pictures here as close as possible, and the output would be PBR textures. So you're not gonna get a finished material or a shader, you will get individual textures that you can map into whatever material that you need. The downside is that not all materials can be acquired with this method, but the upside is that you just have textures and you're basically very platform independent on where you use these textures. And the other method, and that's the method that VRScans use, is the BTF method. So the BTF method is different from the BRDF method. It doesn't try to understand and analyze the data that is stored in those pictures in here. It doesn't try to find parameters to remap that basically. It just stores all of this data here in this huge database, and then basically outputs a compiled shader that you can use directly in the render engine itself. So the benefit of using this method is that there are certain kind of shaders which the BRDF method cannot really replicate correctly, complex materials such as holograms and so on, because everything always needs to be output in PBR textures. So only the BTF method can make sure that basically any kind of material is correctly captured. But the downside is that you can end up with very huge file sizes, because all of this image data here has to be stored in this database. And we're gonna see later on when we use the VRScan materials that the file size can become quite big. And the other downside is that you don't have really much influence of the shader itself, because it's a finished compiled shader. There are certain kind of elements which you can still tweak and so on, but in the end you kind of lose flexibility compared to the BRDF approach. So as usual with any kind of methods, there are up and downsides. Just want to make sure that you roughly understand the difference between those two different approaches. And now let's check out the VRScans materials, how we can download them, how we can render them and modify them in our scene. So if you purchased a license for VRScans, you can find the whole scans library in your downloads folder. And there's a own tab here, which is called VRScans. If you click this, you can see that the whole library will open. And there's a lot of different options to basically filter and select different kind of materials. You can see at the moment there's 2,708 materials in this library. In order to find the material that you need, you have a couple of pre-selection types here. You can even filter by color and a lot of different other options so that you can find the material that you want. So let's say, for example, we are looking for a green car paint. I can just filter for car paint and then check here the green material color. And then it will show me everything that is classified as a green car paint. I think some of those are classified wrongly. For example, this one here I wouldn't necessarily say is a green car paint, or this here, for example. But I mean, for the most part, it seems to be correct. So let's choose, for example, this car paint here. And then it opens this own preview page, and you can open a bigger preview picture here to see all of the details of the material. If you like this, you can download it. You can see the file size here of this shader is around 70 megabytes. Depending on what kind of shader you download, this file size can become quite big, up to a couple of 100 megabytes from what I saw so far. So always keep that in mind. So you can download this, and I will also download a bunch of other materials. And then let's switch to 3ds Max and try them out. So now in 3ds Max, I have a very simple scene here set up just with a shading dummy that we can apply some nice shaders to. And if you want to know how to build this kind of scene, I have our own dedicated video that you can find in my channel. The link should pop up somewhere on the screen right now. So now let's find out how we can actually use the scanned materials that we downloaded just now. For this, we just need to go in our material editor and create a new V-Ray scanned material. So you can see its own dedicated material. Once you open this, you can see that we have now a new material where we are able to load our scanned material into. So let's just open a folder where I downloaded a bunch of different materials already. And you can see the file size also varies quite drastically. Some of them, like this hologram here, for example, become quite big, 300 megabytes, while some of them are quite small. So let's start with, for example, this aluminum carbon shader here. Then once you load this into the V-Ray scanned material, you can see that now something is happening. Our shading preview here updates. We can then assign our material to our shading dummy. So as you can see, we have some kind of result already, but it doesn't really look like the preview from the VRScans library. In fact, this is the preview of the material that we downloaded. And at the moment, it doesn't really look the same. So the question is, why is that? So by default, all of the VRScans materials are UV based. That means your geometry where you apply the shader to needs to have some UVs. And our geometry here has some UVs, but at the moment, the tiling from our material doesn't really match the physical size of our geometry. So we need to adjust the tiling for our material. So there are multiple ways to do that. For example, you could first of all scroll to this columns tab down here and then just adjust the tiling here manually. You can see now this pattern becomes smaller on our shading dummy, but I think the best way would be to use this handy button up here, and this will adjust the UV tiling based on the size of this object in your scene. So it will measure how big this object is and then compare it to the sample that was scanned and then just adjust the tiling accordingly. So once we click that, we can choose our object in here, and we can see now the tiling here is automatically adjusted. If we scroll all the way down here to this columns tab, you can see now these tiling values here are placed in here automatically. We don't really need to find the correct value to get a correct result. If I feel the automatic tiling is too small for my object, for example in here, I would think I would like to make this pattern a little bit bigger. You can easily use this tiling factor here. For example, let's tile it with a factor of 0.5, and then it will become twice as big, so to speak. So you can first of all adjust the UV tiling to your object, and then if you don't like the result, use this tiling factor here to modify the result that you get. So at the moment we use a UV based workflow. That means our object needs to have some UVs in order to work correctly. In case the object does not have any UVs, I can just emulate this by adding a new UV map and basically destroying or make our UVs of this shading dummy here useless. Then it's also easy, we can use a triplanar mapping workflow. So once enabling this use triplanar mapping, it will recognize that the tiling factor up here and also down in this columns tab is not set to a default value of 1. It recommends to start with a value of 1. So I can do this here and you will see that those values here will be reset. And now with this tiling factor, I can dial in and find the correct size that I want. For example, a value of 0.1 to have a bigger scale, or a value of 0.5 to have a scaling that was more comparable to what we had before with our UV based workflow. Now I can also disable this UV map again here. You can see there's no change because everything is now based on this triplanar mapping. So now let's load a different material to explore some other options. For example, we can choose this orange wax that I downloaded before. Here you can see the file size is already 200 megabytes. That's also because this one captures some translucency. So you can see the shader even supports this kind of like subsurface scattering effect, where like here on the edges, basically you can see a little bit of the light bleeding through. That's also quite nice that this is supported in the VRScans materials. If you don't like this effect, you can disable the transparency in here. So once you do that, you can see that now this kind of effect here disappears and now it appears again. But normally you should always leave the transparency enabled because otherwise your material might not be correctly displayed. So now the question is how we can modify the appearance of our shader. And that's the downside of these scanned materials. They look pretty realistic. They look basically exactly the same like the scanned material itself. But there's not a whole lot of options to basically tweak those shaders because it's like a compiled shader based on this BTF method that I explained earlier. And that's why there's not a whole options to really customize that. Luckily there are a few, and I think the most important options are there. So you can use this appearance tab in here. And there's two different options here. The filter color, that's basically just a multiplier. So if this is enabled and set to white, then nothing happens. And you can then just multiply, for example, a color here on top of everything. And if you set it all the way to pure black, basically everything is multiplied by black. So the whole thing basically disappears. So the filter color is useful to some extent, but I think the better way to modify your shader is using the paint color. So once you do this, all of the original properties of the shader stay untouched. So it's not really gonna mess up with the reflectivity, or in this case, the translucency and so on. It just affects the color of the material. So you can choose, for example, here, like this kind of bluish wax, or like this kind of greenish wax. And let's choose a little bit darker color so we can see something. So you can see you can download, for example, a orange wax and then make it to a green wax without any problems. But you can't really go in and change a whole lot of other things. For example, like the exact pattern here of these details that you can see in here, or the depth of the translucency and so on. All of this is in the scanned material itself, and you can't really play with this a way that you're used to, like for example in the V-Ray material. There are a few more options. So once we disable this again, we can also play with the gamma and like give it a more contrasty look or a less contrasty look, for example, or increase the saturation or decrease it, for example, to half the amount of saturation and so on. So you can see there's some kind of tweaks that you can do to the appearance, but that's pretty much it. Like for the main part of the material, there's this advanced tab in here, which I'm not gonna go into details in this tutorial, because I think like a lot of stuff in here, its effect is extremely subtle and it's very difficult to demonstrate that. So normally I didn't really find any drastic result or any drastic difference playing with these kind of settings in here. So let's now check out this last tab in here, the clear coat tab. And that's worth mentioning that basically every material has the option of enabling a clear coat, and many of the materials already have this enabled by default. So instead of demonstrating the clear coat on this material, let's add a new V-Ray scanned material. Let's choose, for example, green car paint that I downloaded earlier. So once I assign this to the object, and let's also adjust the UV tiling here to the shading dummy scale, you can see now we have quite a nice car paint here already showing up. So let's scale down to this clear coat tab. You can see this one has the clear coat enabled, and there's also a value here in this IOR value. This one is set to 1.396 here for this material. What is important to know is that the clear coat itself is not actually scanned. This one is fully parametric. As you can see, you can define the glossiness, you can define the IOR and so on. So if I disable the clear coat, you can see this is actually what the scanner acquired and what is also saved out in the material itself, because the clear coat itself is very difficult to scan. So that is normally not really part of the scan. And then it kind of uses this hybrid approach that it has like the option to enable a fully parametric clear coat in here. So what apparently is captured is the correct IOR value and so on. So if a material has a clear coat, then it would also be enabled in the scan material, and then also the correct IOR value would be set already by default. But nonetheless, if you want to, you can really play with the value in here. For example, you can reduce the glossiness, make it very sharp or very blurry, for example. So you can see this one here is fully parametric. You can also change a different IOR value and so on. But basically it's nothing else than what you can do in the V-Ray material, for example, by enabling just a clear coat layer on top, which is fully parametric. So now let's talk a little bit about the pros and cons of using these kind of scanned materials. And here I already populated my material editor slot with a few of the materials that I downloaded from the Chaos library. And I will demonstrate some of the advantages and some of the disadvantages that I found based on those materials up here. So first of all, let's check out, for example, this hologram shader in here. This one was scanned from, I think, a 100 euro bill. And you can see the result that you get can be really astonishing, because like building this kind of shader that kind of reflects in this way to the light, you can see we have this kind of reddish reflection in this angle, and then this kind of greenish reflection in this angle and so on. It is not totally impossible to rebuild this basically using a traditional V-Ray materials, for example. But like using this kind of scanned material, it gives you the perfect representation of how this hologram here really looked like straight out of the box. However, there are some things that could turn into issues. For example, if I check out here this hologram material, you can see that the file size for this is already around 300 megabytes. And actually, if I zoom in, you can see that the resolution for this is really not very great. So you can see it's basically not really usable to have any close-up angles. And you could imagine if this kind of small resolution here basically requires already 300 megabytes, then if you want to have like a much higher resolution for this, something, let's say, more production ready, then the file size for these scanned material can become quite huge. So that's just always something to keep in mind. Basically, if you have a very complex shader, then it would need to acquire a lot of data to be represented accordingly. And then you would possibly need to sacrifice in the resolution in order to still get a file size for your shader that is still kind of workable. Another potential issue that you could run into is some very visible tiling. So for example, in this material in here, you can see a very visible tiling happening. So unfortunately, there's not much that you can do about this. So in, for example, a VRAM material, when you use some texture maps, you could use some stochastic tiling and so on to reduce this kind of tiling effect and to improve the overall result. But in the scanned material, you basically just have to take it as it is, and there's not really any way to customize it. Another thing is that your render elements are not split up the same way like in your typical VRAM materials. So for example, here, all the information is baked into the lighting and GI channel, while the specular and reflection channel is completely black. And the diffuse channel also seems to have some highlights, which basically shouldn't be the case, and so on. So since they are scanned materials, they don't really work the same way like, for example, the VRAM materials. And the render elements might behave a little bit different than what you expected. So after talking a little bit about the cons, let's also talk about the pros of those materials. And what I also like is that even though they are scanned materials, there's still some amount of flexibility to kind of customize them. So for example, here I have this kind of silvery chrome, and just using very simple methods, I can make like a dark or black chrome out of it, and then also add a clear coat on top of it. And you can get a quite different result just by playing with these appearance parameters in here. You can then, for example, download a material that's close enough to whatever you require and just make some basic customizations and then get very fast the result that you want. Also, overall, I really like the appearance of those scanned materials. For example, here we have this kind of greenish car paint, and I think the car paint is really captures quite nicely. What I really like, for example, if you notice this part in here, it's actually very difficult to replicate something like this with the, for example, normal VRAM material. Here I try to replicate like a simple car paint shader, and I couldn't really get the same kind of result with the standard VRAM material. Sure, you can get something that looks a little bit more similar than the original scanned material, but you can't really get exactly the same kind of result. And I think here overall they look kind of similar, but for example, this part in here, as said, I just prefer much more how it's in the scanned material. I used also a V-Ray car paint shader to kind of try to replicate this. I think here this part looks a bit more similar, but then the other parts, they don't look as nice as with the scanned material. So overall, I think in this case, I like the result of the scanned material here the most. And just in this case, I would totally use the scanned materials instead of the other two materials. So the idea about scanned materials is basically that if you need to visualize a material and it needs to behave exactly the same way like the physical real material, then VRScans is a great solution, because you can basically send in material samples to Chaos and they would scan that material for you, of course for a fee, and then send you back the scanned material. And then you can use that exactly in your scenes and you get a perfect representation of the original material that you send into. So that is one use case. You have basically a material and that needs to be shown exactly the way like how it behaves in the real life. Other use cases could be that you don't really have any material that you want to scan, but you want to have access to this huge library of different materials, then I think VRScans is also a good solution, but you would need to be willing to make some compromises on the customization of those shaders. So that's just something that you would need to be aware of. So that's my personal opinion about the scanned materials from Chaos. If you watch this video until here, chances are that you also enjoy the content that I provide over on my Patreon, where you can download all of my scene files for all of my tutorials and watch additional bonus content, whole courses, and so on. So see you over there. Otherwise, in the next tutorial here on YouTube. Take care and see you then.